Hello students, today I am here with Determinants part 2. Today children we are going to discuss an important aspect of determinant, that is how to find adjoint of matrix using determinants and inverse of a square matrix. So let's begin with minor of an element of a determinant. So what is a minor? Minor is found with respect to an element. Here it is defined. Minor of an element Aij of a determinant is the determinant obtained by deleting its ith row and jth column in which Aij lies. It is denoted by Mij. Here M will be capital. So children, suppose you want to find minor of A11, then simply it will be M11, and as it is told in it is said in definition, strike out rows and column lying along this element, that is first row and first column. So strike out. After that you get a determinant of 2 cross 2. That will be the minor of element A11. Minor is always of order n minus 1 cross n minus 1 if the given determinant is of order n cross n. Means it will be one sort from the order of the determinant. So this is minor of an element of determinant. Similarly we can find M12, M13, and there will be here number of elements is 9, so there will be 9 minors. Let's move to cofactor of a matrix. Cofactor and minors are interrelated. Here you can see cofactor of an element Aij of a determinant is denoted by Aij. It will be capital Aij. I repeat it, Aij. And Aij is equal to minus 1 raised to the power I plus j. I plus j, where I plus j is, this is the suffix of index of this minor, or you can say of this cofactor. So simply if sum of I plus j is even, it will be positive, and if it is odd, it will be negative. So it is cofactor. Now move to adjoint of a matrix, of a square matrix. All these will be found for square matrix only. So adjoint of square matrix, adjoint A simply be like A D J A is equal to A11, A12, A13 column wise, A21, A22, A23 column wise, A31, A32, A33 column wise. So this will be adjoint of a square matrix. Children, here is an example. Example 2. If a matrix A is equal to 1, 2, 3, 4, minus 1, 2, 3, 4, 5, find its adjoint. So simply we first find cofactors of matrix A. Cofactors, you know that cofactors Aij is equal to minus 1 raised to the power I plus j into mij. So we use that. So first we find A11. So we strike out all the elements lying first row and first column. Now you have determinant of order 2 cross 2, minus 1, 2, 4, 5. Now expand is like order 2 cross 2 determinant, minus 5 minus 8, that will be minus 13, and here A11 index is 1 and 1 plus 1 is 2, which is even. So minus 1 to power 2 will be positive. So we can, here sum is even, so we can take positive. So A11 is equal to minus 13. Now for A12, we strike out second column and first row. So we got determinant 2, 3, 4, 5, and it will be minus because 1 plus 2 is odd, so we take negative. Now after expansion this determinant, we got A12 is equal to 2, and for A13 we strike out third column and first row. So we are with 2, 3, minus 1, 2 determinant, and 1 plus 3 is 4, which is even, so it will be positive. After expansion 2 to the 4 plus 3, it will be equal to 7. So we can find cofactors corresponding to each element, and after finding cofactors we simply write formula. Adjoint of A is equal to A11, A12, as I told you earlier, A21, A22, A23, A31, A32, A33. Simply placing values, we are with the adjoint minus 13 to 7, minus 14, minus 4, 10, 19 to minus 9. So this is the method by which we can find adjoint of a square matrix. Now there is a note you can see here. Adjoint, transpose of the adjoint is equal to adjoint of transpose matrix. These two will be equal. There may be questions to which you have to find adjoint of a matrix, and after that you are told to find adjoint of transpose matrix. Then no problem at all. Simply transpose the so far found adjoint matrix. You will get the adjoint of its transpose matrix. Now singular matrix. Any square matrix is said to be singular if its determinant is 0. It is very important, because if matrix is singular, then you cannot find inverse of that matrix. I repeat it, if a square matrix is singular, then you cannot find inverse of that matrix. Okay, so for inverse to be exist, matrix should be non-singular. So this is the definition of singular matrix. Any square matrix is said to be singular if its determinant is 0. Its determinant is 0, singular. If its determinant is not equal to 0, then non-singular. Simple. Now Inverse of a non-singular matrix. Obviously it will be square because we can find inverse of a square matrix only. Let A be a non-singular matrix, then A inverse is equal to, this is the formula, children, note it. A inverse is equal to adjoint of A divided by determinant of A. This is formula for finding inverse of a non-singular matrix. Now here, children, you can see a formula is written here. This is adjoint of determinant of adjoint of A is equal to determinant of A raised to the power n minus 1. Here n denotes order of a matrix. Okay. Another formula is given here. AB inverse is equal to B inverse into A inverse. AB inverse is equal to B inverse into A inverse. Means we use here just like transpose of matrices. In transpose of product of transpose of matrix, you simply write like this, and you take in reverse order B dash A dash. So it is for the formula of inverse of a matrix. Now children, we do certain important problems related to these topics. Our first problem is, if a square matrix A is equal to so and so, then find A inverse. Simply, student, first, if we are told to find inverse of a matrix, then first we shall find its determinant. If determinant is non-zero, then we shall found A inverse, otherwise not. We shall not proceed until we get non-zero non-singular matrix. Okay. So here we first find determinant of A, and you can see here it is minus 4, which is non-zero. So we can say A inverse exists. Now in next step we shall find cofactors of A, simply as you did in previous page, simply finding adjoint of A. This is adjoint of A. Now A inverse is equal to adjoint of A is equal to 1 upon minus 14 into adjoint of A. Simply you found A inverse. Okay. Now move to another question. If A is an invertible matrix of order 2 cross 2, okay, then find determinant of A inverse. Children, note that you can write determinant of A inverse is equal to determinant of adjoint of A divided by determinant of A, simply using formula. So here is determinant of, determinant means like this, and this is a matrix of 2 cross 2, so we can write like this. There will be such kind of means it will contain adjoint of A in all the elements as a multiple. So we can take determinant of A as common. So it will come from 1 upon determinant of A is common. It will come from it will come from adjoint of A, adjoint of, use determinant symbol. Your determinant is given, so use it. Adjoint of A divided by determinant of A, adjoint of A divided by determinant of A. It will be 4 times because it is 2 cross 2 matrix, determinant. Now take 1 upon determinant of A from R1 and similarly from R2. You will get 1 upon determinant of A square. Okay. Now you can see here 1 upon determinant of A square. Now determinant of adjoint A, as I told you in previous page, it was there. Determinant of adjoint of A is equal to determinant of A raised to the power n minus 1. So use here determinant of A to power 2 minus 1. After this calculation, you get determinant of A divided by determinant of A square, and finally we got 1 upon determinant of A. So this is the very important question for 1 mark. Now move to question number 4. In question number 4, determinant A is equal to so and so matrix, B is equal to so and so, and C is equal to so and so. Find the matrix D which satisfies this condition. And condition is that CD minus AB is equal to null matrix. So here assume that D is X, Y, Z, U. You can take any matrix, variable may differ but answer will be same. So it is not restrictions to use only X, Y, Z, U. You can take A11, A12, A21, A22. So for simplicity I have to taken this only. Now first we find CD is equal to, and as you can see here, this is CD, simple multiplication of C and D matrices, and AB, multiplication of A and B matrices. Okay, now this is AB and this is CD. Recall that CD minus AB is equal to null matrix, and if we transpose AB to RHS, then we shall get CD is equal to AB, because AB will be added to null matrix, and we know our past experience, our past knowledge, that if we add null matrix to any matrix, we get the matrix itself. So here CD is equal to AB. Now simply equating, since these two are equal matrices, so their respective elements will be equal, and after solving these equations we shall get the required matrix D. So these are few questions that I discussed with you. If you want to ask more questions, then you can inbox. And children, thank you for watching this video, and I think this video will definitely help you in finding A inverse, adjoint, and question related to non-singular matrices. Non-singular matrix question may be asked for 1 mark. So I thanks to all of you for watching this video, and we shall be there with determinant part 3, and in that part we shall discuss application of determinants, that is finding the solution of simultaneous linear equations in 3 variables. So be ready for that. We will be soon with you. Once again, thanks for watching this video, and if you found useful, then please do subscribe this channel. Thank you very much.